Let's talk about equations that lead to linear or quadratic equations. If we have some fractions where we have the variable x, these might lead to linear or quadratic equations. Also, if we have some expressions with roots where x is inside the square root. Also, there would be this third example where we can transform a number in such a way that, well, here we would have 2 to the power y and here 2 to the power y squared. And if y is an unknown variable and we would denote this 2 to the power y by x, we would get this quadratic equation. Let's talk about this case later and focus on these two examples. First, the fractional equations. Let's consider this fractional equation. In the left hand side, we know how to arrange the denominators to be the same. So we have multiplied the numerator and denominator in the first one by x plus 1 and in the second one by x. And we have shifted this number 1 to the left hand side. Now it has a minus sign there. And we have written the number 1 in this way. All the fractions have a common denominator, so we can combine them. And this is the result. Well, it would be nice to have a plus sign in front of x squared, so we can take the minus sign as common in front of the fraction. Now, fraction a divided by b can be 0 only if the numerator is 0. So we have that this should be 0. By using the quadratic formula now we have a equal to 1, b equal to minus 1 and c equal to minus 1. Substituting these things to the formula, we have that x is something like this. So we use the method where we arrange the fractions to have a common denominator. Other method to solve this kind of equation would be to multiply all the denominators out. So we see that we have the denominators x and x plus 1, and we can multiply with both of these. After the multiplication, we can cancel out x's and we can cancel out these x plus 1's. And the left hand side will be quite simple. We can cancel out these x's and we get the same equation as before. X squared minus x plus x minus 1 is 0. Here we had the same equation. So this second method also works. The second method has a danger related. For example, if we had this equation and we would see the denominators x and 2x and we would multiply with both of these, then x's would cancel out and 2x would cancel out, and we would again get a second degree equation. Well, in this case, the second degree equation, we can solve it by taking x as a common factor in the front. We have that product of two numbers is 0. That's only possible if first of the numbers is 0 or the second one is 0, and we obtain these two solutions. However, this second solution, it's not a correct solution, because if we look at the original equation, we would be dividing by 0. So It's a good habit to always check your answers by substituting them to the original equation. Let's check this answer. X is 3 over 2. The original equation is 1 over x plus 1 over 2x is 1. If we would substitute there 3 over 2, we would get from the first fraction 2 over 3, and from the second one we would get 1 over 3, and together they make 1, so our solution is correct. That's everything what I wanted to say about the fractional equations. Let's now see these root equations. If you want to solve a root equation like this, the idea is that you will take second powers on both sides and solve the equation if it happens to be linear or quadratic. And in the end you should check your solutions by substituting. So let's see how this goes. We have the original equation and we take second powers on both sides. In the left hand side the square root and the second power cancel out and we get just x plus 7. In the right hand side we have 9x squared. Moving everything to the right hand side we obtain this second degree equation, and now we have the coefficients a is 9, b is minus 1 and c is minus 7. Substituting these to the formula we obtain this result. Here 4 times 9 is 36 and 36 times 7, 6 times 7 is 42, 7 times 3 is 21, we get 252. Together with this one it's 253. So these are our preliminary solutions, and if we put them in a calculator we get these values. We should check the answer by substituting to the original equation. If we substitute that x is equal to 0.9, we get that the square root of 7.9 is 3 times 0.9. You can use the calculator to check that this is true. So our first solution is correct. If we would substitute x is minus 0.8 to the equation, we would get that the square root of 6.2 is equal to some negative number, and we find a problem. The left hand side is a positive number and it's equal to a negative number, and this is not true. So we have to cancel out our second solution. We have only one solution for the equation.